Today, we're diving into a paper that proposes something, well, pretty radical for artificial intelligence. It's a new architecture called the Cognitive Reasoning Model, or CRM for short. And look, it's not just about making AI a little better, it's about completely rewiring how it thinks. So let's break it down. The entire idea, the whole inspiration behind this new model, really boils down to this one powerful question. I mean, current AI is an absolute master of prediction, right? It's incredible at guessing the next word in a sentence. But what if we could build a system that goes beyond just playing the odds, beyond statistical tricks, and actually gets into the realm of real logical reason? To really get why this is such a huge deal, we first have to talk about the AI we use every single day. We need to look at its fundamental limits. The paper calls this AI's prediction problem. And this slide just lays it out perfectly. On the left, you've got the AI of today. It's probabilistic. It connects words based on what's statistically likely to come next. Now, this makes them super powerful, for sure, but it also makes them fall into what the paper calls intuitive traps. They're easily tricked. On the right, that's the goal of the CRM, a deterministic system, where a thought isn't a guess, but a logical step-by-step evolution from one state to the next. Okay, so how on earth do you get from a guessing machine to a reasoning machine? Well, the authors say you need a total paradigm shift. You have to throw out the old playbook and bring in a new framework they've named cognitive physics. Now, cognitive physics sounds incredibly complicated, I know, but the idea behind it is actually pretty elegant. Think of it like the laws of motion in the real world. You know, just like gravity dictates how a ball is going to fall, these cognitive physics principles are designed to govern how a thought process unfolds. It's a set of rules that ensures every single line of reasoning is coherent and logical from the very beginning to the very end. And this shows you one of those core rules in action. For thinking to be stable, the CRM says you have to follow a strict hierarchy. You can't just jump straight to making a decision. No, first, the system has to establish its loyalty to core principles. Then it defines its identity. Then its perspective. See? Each step is built solidly on the one before it, creating this unshakable foundation for actual reasoning. So we've gone over the theory, now let's pop the hood and actually take a look at the key parts that make this whole cognitive reasoning model tick. It all comes down to these three core components working together. You've got the dice engine, the identity anchor, and the memory pyramid. And each one is designed to solve a really critical problem that today's AI models are constantly struggling with. First up is the dice engine. This is the heart of the whole system. Now, instead of just predicting one single path forward, DICE explores a problem from all angles at the same time. We're talking analytically, creatively, strategically, the whole shebang. It isn't guessing. It's literally evolving its own state until it settles into the most stable configuration, which represents the most logical solution. It's a deterministic hunt for the right answer. So how do you keep that kind of open-ended exploration from just spinning out of control into total chaos? Well, that is the job of the identity anchor. You can think of it like a powerful center of gravity for the AI's thoughts. The paper calls it a high-stiffness attractor, which is just a fancy way of saying it's a super strong force that keeps the AI's reasoning from drifting off course. This is huge because it directly tackles major safety issues like hallucinations or the AI forgetting its goals. It's architecturally designed to keep the AI on track. And finally, how does it get its information? Forget about a limited context window. The CRM uses what it calls a memory pyramid. The really core principles are hot, always right there, instantly accessible. Active methods it's using are warm, and then these vast archives of knowledge are cold, ready to be pulled in whenever they're needed. This basically creates near unbounded access to information, all without the insane computational cost. Okay, the architecture sounds amazing, right? But does it actually work? This brings us to what might be the most jaw-dropping part of the whole paper, the results from what they called the zero to hero test. So here's the setup. This is not a memory test. The researchers gave the CRN just a single example of how to solve a really tricky counterintuitive problem. They taught it the method. The real test, the big question, was whether it could then take that abstract method and apply it to a totally new problem it had never seen before. This is a test for genuine understanding. And the results are, well, they're just staggering. A baseline AI, kind of like the models we have today, was totally fooled by the problem. It scored pretty much 0. But the CRM, after seeing just one single example, it was already scoring over 80%. And then when they asked it to generalize that method to a whole new class of similar tasks, a perfect score. 100%.
And let me be clear, this wasn't a lucky guess. The paper really stresses this is deterministic accuracy. It got it right every single time, repeatably. This shows a systematic, reliable level of performance that probabilistic models, even the giant ones, really struggle with on these kinds of tasks.
So, a perfect score on a tough reasoning test is one thing, but what does this all mean for the real world? What are the implications of an architecture like this? This is where it gets really, really exciting. There are three massive takeaways here. First, efficiency. Because it's not a brute force statistical monster, the CRM can pull off this complex reasoning on regular consumer hardware. Second, safety. Alignment isn't something you try to bolt on later. It's baked right into the architecture with that identity anchor. And third, auditability. You can trace every single step of its reasoning process, giving you a completely transparent log of how it got to an answer. So what we've just covered is a deep dive into a potentially revolutionary idea. I mean, we've spent years getting incredibly good at building AI that can associate patterns. And the results have been amazing. But this paper leaves us with this one profound, lingering question. What happens to our world, to our technology, to our future, when we finally build an AI that can truly understand?